Graph number 2 on the handout. Looks like this. Somewhat, maybe. And I called that g of x. All right, so what about local mins and maxes? Well, I've got a local min here, right, at 1. And then a local max here at 4. Am I looking at that right? I think so. Okay. Okay, but from the perspective of derivatives, well, same thing, isn't it? We talked about this last time, but what are x is 1 and x is 4? Well, they're critical numbers, okay? Once again, yeah, the local min and local max occur at a critical number. And in this case, it's derivative equals 0, but we can also have them at derivatives not exist, corners and that sort of thing also breaks. But anyway, yeah, so the critical numbers is once again going to be important. But now, let's tie that in with our increasing and decreasing discussion here. Do you notice that for this local min here, what is the derivative on this side of the local min? The derivative here is negative, right? The derivative is negative on this side, but what about the other side? The derivative is positive. So if I know, don't have the graph here, but if I know on this side of that critical number, my derivative is negative, and then on the other side is positive, then at the critical number, you've got yourself a local min. Okay? With me? If it's negative on the lower side, positive on the upper side of that critical number, you've got yourself a local min. Now what happens for a local max? It reverses, doesn't it? To the left of your critical number, you've got positive slope. To the right, you have negative slope. So you got positive to negative. Okay? That is called the first derivative test. First derivative test. If C is a critical number, of continuous function f. The A part of the first derivative test says this: if f prime changes from negative to positive at C, then f of C is what? Fill in the blank. If f prime changes from negative to positive at C, then f of C would be a local what? Well, if we change from negative to positive at C, negative to positive, local min. F of C is a local min. B, if f prime changes from the other way, positive to negative at C, then f of C is a local max. Now, can you think of something else that could happen? Is there a C part to that? Yes, there is. Okay. Yes, there is. C part is this. if f prime does not change sign at C, then what happens? Think about that. Well, let me give you a for instance. Say I have f of x equals x cubed. All right, what are my critical numbers here? F prime is 3x squared. So the critical number is 0, isn't it? But if you look at either side of 0 here, the derivative at 0 is 0. I'm sorry. I want a negative 1. Okay. The derivative at negative 1 is 3. The derivative at positive 1 on the other side is 3. Doesn't change sign. It goes positive. You got a positive slope here and a positive slope here. You don't change signs. Well, what happens at x cubed? Well, that one's an easy one to graph. Is there a minimum or maximum? No. Okay, so that's what we're saying. That can happen. You can have it where you got increasing here and increasing here. When that happens, you don't have a maximum or minimum. If it's negative, negative, you don't have a minimum or maximum. So if f prime does not change signs at C, then f of C is neither max nor min. Okay, so those are the three things that could happen. And that first derivative test tells us all about that. Okay? All right, so let's find, using this first derivative test, using the first derivative test, find the local extrema for f of x equals negative x squared minus 3x minus 40. Yeah, negative x squared minus 3x minus 40, okay? Again, it's not too complicated of a function, but we will get some more, much more complicated here as we go along. So let's understand it, how it works for this one. Then we'll move on to others. All right, well, first of all, what do I mean local extrema? Local maximums and minimums, okay? That's just their word sometimes they'll use. Don't let that throw you off. Yeah, so all I'm looking for is local maxes and mins. That's what that word means, okay? Or also known as relative ones, right? Okay. Using the first derivative test, all right? So to use the first derivative test, probably should get the first derivative. The first derivative says negative 2x minus 3, your first derivative. And then we get our critical numbers. Again, f prime equals 0, or f prime does not exist. And again, there's not any for that one, for does not exist. Don't let that fool you, though. There will be some where that comes up, but not now. All right, so anyway, f prime equals 0. Set that equal to 0. That's my critical numbers. Add 3 and divide by negative 2. Negative 3/2, negative 1.5. All right, and again, I'm just going to use our little chart here and break it up at the critical numbers, which in this case we only have 1. So the graph breaks up at negative 1.5 into 2 pieces. So what do I have to look for? Well, the first derivative test, just like the increasing and decreasing, it's all about what happens on either side. So I need to check a value of the derivative on each side of our critical number. Well, on this side, we're looking at to the left here of negative 1.5, so let's do negative 2. So what is the derivative at negative 2? I'll plug in negative 2 right here. That looks like it's going to be positive 1. So the derivative is positive. On this side, and I like to go ahead and draw a little arrow showing general upward trend there. Help us out. And then on the other side, well, let's pick 0. Derivative on this side, negative 2 times 0 minus 3. What do we got? Negative 3. Negative derivative. That's downward. I go from positive to negative. What have I got at the critical number? It's going to be a max, isn't it? So f of the critical number, negative 1.1.5 or negative 3/2, is a local max. Again, there's other ways of figuring that one out, but if you understand it, to do it that way, that's a good way to do it. Okay? All right, so we talked about x cubed, but let's do another one. All right, so let's go all the way through it. Another one here. Let's do both the increasing and the local mins and maxes. Okay? All right, for f of x equals minus x cubed plus 6x plus 7. Number 1, find the intervals of increase and decrease. Maybe the way they say it. And number 2, find local maximum and minimums. Using the first derivative test. Well, the good thing is you kind of kill 2 birds with 1 stone, because if you do the increasing and decreasing, then the chart also works for the first derivative test, so it all goes hand in hand. All right, so my first derivative is negative 3x squared plus 6. And so off of that, I want the critical numbers, which the only ones here, critical numbers I would give would just be setting it to 0. However you want to do that, if I subtract 6 and divide by negative 3, I get 2 equals x squared. So what are my critical numbers? Plus or minus square root of 2, plus or minus about 1.4. Okay. And so that'll set up this chart. So I want to go, let's just denote negative square root of 2, positive square root of 2, and the graph breaks up at those. If for these, all I want then is just a value in each one, do the derivative of that value. Let's see, like I said, that's 1.4, negative 1.4. So how about f prime of negative 2 for this side? So do the derivative value at negative 2, so that would be what? Negative 3 times negative 2 squared would be 4, plus 6, that's negative 12, plus 6, that's negative 6. Derivative is negative. That's down. Right? What about in the middle? Well, the good one there would be what? 0 is always a good choice for just about any function, whether it's derivative or not. So that'd be what? Negative 3 times 0 squared plus 6. Hey, that's positive 6. So f prime is positive in that range. So that's going to go general movement upwards for the whole interval there. And then f prime on this side, how about positive 2? Well, at positive 2, I'm going to get about the same thing I get at negative 2, aren't I, for this one? 2 squared is 4, so negative 3, so that's negative 6 also. So f prime is negative in here, downward trend there. So what have we got? Let's start with number 1. Increasing and decrease. Where am I increasing? Where am I decreasing? Well, it's in the middle, isn't it? Increasing in the middle. How would I write that, though? For the critical numbers, right? Between the critical numbers. So negative square root of 2, comma, positive square root of 2, and then what about the endpoints? Do I bracket them or parentheses? Parentheses, because at the endpoints here, those are my critical numbers. That's where it equals 0. So it's not increasing, it's not decreasing there either. All right, so decreasing, well, it's about like the other one, go from negative infinity to this negative square root of 2 first critical number, and then go from square root of 2 on out to infinity. Usually you'll see a union sign between them there. All right, so let's move to local min and max. Got a local max? Well, yeah, here again, you look at what it changes from where to where. If I go from at this critical number, so the local min and maxes are going to occur at the critical numbers. So I'm looking on either side. So at this critical number, negative square root of 2, no, it's going down and then up. So that's not a max. But at square root of 2, I'm going positive to negative. So that's a local max, isn't it? Right here at square root of 2, that's a max. So we just say f of square root of 2. And if you want to, the book may go ahead. If you want to, you can plug, I don't make you, but if I wanted the actual value there, it's f of square root of 2, so I'd have to go back to this one. Plug in square root of 2 here, square root of 2 here. A lot of times that's a lot of work, so we'll forego that if we want to. All right, then local, what about the local min? Well, we just said at negative square root of 2, it's negative to positive, so there's a min right there, isn't there? With me?